Hello, hello, hello. So we're slowly moving into robotics and architecture. So with this tutorial, I'm going to kind of begin doing that. And we are going to look into how we can control a form in Grasshopper with an Arduino sensor, right? So something that is physical, something that is, in real life will control our geometry in Rhino. So first of all, the layout, right? What do we see here on the screen? So this is webcam number 1, right? This is webcam number 2, right? So you see my table. On the left-hand side, we have the Arduino Arduino coder or the developer interface. I don't know how to call it. You can just download it for free. And then on the right-hand side, we have Rhino. I'm using Rhino 7, but this will work on Rhino 6 as well. And we have Grasshopper. And in Grasshopper, I already have a definition that I've kind of done to just test if this thing will work. So if I get stuck, I will use it as reference. But I guess let's begin. Right. So the first thing that we need to talk about is probably hardware, right? What kind of hardware do we have? Let me make this bigger. And by the way, all of the links to what I'm using are going to be in the video description, right? So if you want to order it, you can just click on those links and get it. So I'm using an Arduino Nano, which is right here. Focus. And it's actually a Chinese version of the Arduino Nano. So I think you can get like 5 of these for, was it $10, something like that? So these come in pretty cheap. Link in the description again. And I'm using a moisture sensor because that's the only kind of sensor that I have. And these are also on Amazon. I don't know the price of them, but also pretty cheap. And some wires. We will only need 3 wires for this. And for some reason, I decided to use green, white, and black because, with black background, that's going to work perfectly in showcasing how it works or how it connects. Also, a USB cable, right? Something to connect the Arduino to my computer. So first things first is wiring everything up. Let me actually make this even bigger. Whoop. And then this goes here. There we go. So wiring this thing up. Just read, basically. Here it's going to say, well, if it focuses, there we go. Ground, GND, VCC, and A out, right? So I basically just wire my black wire to ground, my white wire to voltage, and my gray wire to the signal. Just like, come on, just like that. Bam, that's done. And then I need to wire the corresponding part to my Arduino. So here I have my, you probably can't see it, can you? Zoom in. Come on, focus. Jesus Christ, camera. Today's camera is not great. So here I do have the naming of all of the pins, all of the inputs. So just at this point, just trust me, bro. Ground connects to ground. VCC connects to 5 plus, which is, or plus 5 volts, which is 5 volts. And then for the input, for the digital or analog input, I can use any one of the pins that say between A0, A1, A2, A3, A4, A5, A6, or A7. Any one of those will do. So again, black to ground. So ground connects to ground. VCC connects to 5 volts. And gray connects, in this case, I'll just connect it to A7. So analog input 7. That's it. We have our, where are we? We have our wiring done. Easy. Now, we take our USB cable connect it to our, sorry for the noise, connect it to our Arduino, like that. And the other end is going to connect to the computer. I'm just going to take my USB extension because my USB port on my computer is pretty far away. Like that. I have a USB extension now. And bam, we're golden. Now this is working and this should be glowing. Yes, it is. Green light. We are good to go. And we have our moisture sensor here that you will see somehow like this. This is gonna be a little bit weird, but it is what it is. Okay. Oh my God. Falling apart. Come on. There we go. That's good. So now let's make the camera small again. Like that. Push it up. Like that, so that you can see it. And let's continue. So now, with Arduino connected, we need to kind of tell this part, this software. I'm using, by the way, Arduino 1.8.13. The software to connect to our Arduino to tell it what kind of board is this and what kind of port are we going to use. So to do that, we just go to Tools. And for board, we choose, well, in my case, I'm using Arduino Nano. So I have chosen Arduino Nano. Since this is like a Chinese copy of the original Arduino Nano, I need to use the old loader, not the new one, but who cares? And then for port, I use the only one that I have stuff connected to, COM5, right? So if in your case, if you have more than one, just try one of them. If it doesn't work, then try the other, right? Okay, so we have that. Now it's time to code a bit, right? And it's not going to be anything difficult, right? Basically, what we want to do is this moisture sensor needs to create a number according to the moisture. You know, if I'm touching it and my fingers are kind of moist, then it needs to change a number that this moisture sensor is giving to Arduino, right? That's how it works. So I am just going to add a line, and I'm just going to say integer int. I'm just going to call it output value. And then that semicolon, right? Is it semicolon? I think it's semicolon, right? Dot colon, dot comma, right? Thing. So int output value. This thing here will say that I am going to use a number that's a full number, and it's going to basically I'm just calling it my output value. You know, the value that I get from the sensor. Enough of that. Then void setup, this is something that happens when Arduino starts, right? And void loop is something that constantly keeps happening. So is basically a looped function, right? So it's being repeated. So for the setup, the only thing that we need to do is we need to run a serial port, meaning it's serial port is, don't worry about it. Maybe that's not for this tutorial. So I'm just going to write serial.begin, and then in brackets, I'll write 9600. That is our. It's like a. Is it a bit rate? It's not a bit rate. I think it's explaining what it is somewhere here. It's baud rate, right? So don't worry about it. Just use 9600, and let's just get this going, right? So serial begin, we're basically initiating the port, right? And we're initiating data transfer within the port. Then for void loop, what we will do is we will say output, output value. Remember, that's our number right here, output value. Equals, so I'm going to actually give it a number. Output value equals analog read with capital R in brackets A7. Why is it A7? Oh, and semicolon at the end. Why is it A7? That's because my pin that I've connected my the signal wire to, the gray wire, is connected to a pin that is that says A7, right? Analog read A7. And then all I need to do is serial dot print ln, print line, in brackets, output value, semicolon. And let's just give it a delay. Delay 50. So it's going to, and semicolon. So it's going to test the moisture every 50 milliseconds, and it's going to give me a value, right? So now I can upload this. Click on upload. Oh, and it's going to ask me to save it. So I'm just going to say YouTube Arduino Grasshopper. I don't know. Hit save. And now it's, as you can see, it's uploading. And it's going to start blinking here. And it is. You can see the blinking. There we go. It's done. It says done uploading, right? Nothing really changes here. But now if I click on the serial monitor right here, this icon right here, click on that, it's going to say COM5, and here it gives me values, right? So it's giving me values, and right now it's like 809, 807. If I take this sensor, right, and I just touch it, right? So I just touch it. Immediately you can see that I'm nervous because now it's 460, meaning that my fingers are kind of wet. If I put it in my mouth though, that's cool. My tongue is as wet as my fingers. That's interesting. Anyway, enough of the weird stuff. This works, right? The wetter it gets, the smaller the number is. And I can see that it ranges between 400 and 820, something like that. Okay, let me close that. Right, so we're not looking at it. And actually, now I don't need this anymore. So I'll just close my Arduino altogether. Right, we don't need it. We already have done the reading part. We close that. Back to Rhino. Maximize that. Maximize that. Let's actually do it this way. Hello. Let's do it this way. Like that. Turn off that. You go here, or maybe here. Make myself smaller. And this way. There we go. So now, in here, I need to actually talk with Arduino through Grasshopper, right? So how do we do that? Well, the first thing is using Firefly, right? That's the plugin. That's the plugin that we're going to be using, Firefly. You can download it from Food for Rhino, and just keep in mind it has 32-bit version and 64-bit version. You want the 64-bit version, not 32 bits. Okay, so you just download it, and you will find Arduino tab here. And what you want to do is you want to open up the Arduino port so that you can listen on at what this moisture sensor is actually saying, what kind of number it's giving, right? So I will say com ports available. First, we check what kind of ports there are available, like that. And I can see that if I just grab a panel, it says 5. That means port 5. And it's actually the same port that we used in our Arduino, so it makes sense. And then under under Arduino, we can open or close it, right? So open, close port, we choose that one. Bam. 3 inputs. First one, is it open or closed? I will want to open it, so I will toggle. I will use toggle for this. And for now, we keep it closed, so toggle is set to false. Then port. Well, we have the available ports here, and it's port number 5, so I just connect it, like so. Easy. And then the last one is the baud rate. Remember, 9600, the number that we used? This needs to match. If it doesn't match, it's not going to work. 9600. Bam. Opened up. Well, actually, no, it's not opened up. It's closed right now. What am I saying, right? Because toggle is set to false. If I grab a panel, by the way, // double click, // creates a panel. The serial port is closed. You must first open the serial port before reading or writing values from the Arduino. Okay, sure. Double click on the toggle. It's true. Hooray, the serial port is open and you may now begin reading or writing data to the serial port. Okay, so we have opened up a connection to the Arduino within our Grasshopper. Next step is actually writing something, or not writing, reading something from the Arduino. In this tutorial, we're just going to read. So we will use serial read, generic, bam, and it's gonna ask for 2 things. Start reading and port number, right? So port is going to be the same port that we have available. That's easy. And start is going to be another toggle. Boolean toggle, right? Connect it to start. Double click on true. And now we are reading. So let's see what kind of output messages we get. Output 828, right? Message. Now reading. Values from the serial port. There's a problem, right? 828, while this is indeed a value that we get from our sensor, it's not updating, right? It's being, even if I like put it in my mouth, see, it's not updating. It's still 828. The only way of how I can make it update is if I toggle it to false and to true again. Now it's updated, right? I'm holding it, so that's why it's 530 now, because again, my fingers are wet. So 530, now I let it go, update it, 827 again. So it's not updating the way we like in real time. How do we make it update? Well, for those of you who are using Rhino 6, it's called timer, right? For those of you who use Rhino 7, it's called not timer. It's called something else. Trigger. It's called trigger, right? But it works in a similar way. We just, for a timer, you just right-click on the timer, or for the trigger as well, you right-click on it. For interval, you choose 50 milliseconds, bam, and you just connect it this way, right? You just drag out of it and connect it to the read. So it's going to trigger a refresh for this node every 50 milliseconds. And you can see this number is now kind of changing. If I hold it, bam, or put it in my mouth, see? Great, now we can control it. Now we're golden. Okay, for this, we need to create some sort of a form, something that will work. And I will just grab a little bit of coffee and we will continue. So I drank my coffee and now we continue. So again, this guy is calculating correctly, and you can always just connect a sphere to it and a sphere radius to it and make the sphere contract and expand according to this number, but that's kind of whatever. That's kind of boring. Let's do something more fun. So I've decided to do like a how is it called, isotropic moisture bending, something like that. When wood gets wet, or one part of the side of the wood gets wet, it bends, right? We are going to simulate that with Kangaroo, and we're going to hook up Arduino to trigger that bending of the wood. So there's kind of an interplay between moisture and the actual plate bending and so on. It's gonna be fun. So the first thing that I want to do is create. How do we do this actually? Do we just do a rectangle? Yeah, let's just do a rectangle. So I'm just going to create a rectangle in Rhino, starting from 0, and I'm just going to give it like 10 by 10 by 10 millimeters or whatever, right? Just a rectangle, and I'll use planar SRF, planar surface, to create a surface from that rectangle. I know this is a weird way of how to create a surface, but this is the one that I'm used to, and we're sticking to it. So we have this going. Then I'm going to just copy that rectangle, maybe 1, 2, 3, 4. Let's go for 5 times, right? That doesn't matter. So we have a bunch of these rectangles here. So now I'll just move this a little bit to the side. I will reference them in as a brep or as multiple breps. So right click, set multiple breps. All of these get referenced, enter, bam, they're now in Rhino. In Grasshopper, right? So now I can just hide them here so that they're not in the way. So these are breps. I will need meshes. By the way, just to kind of explain what I'm after, just so that you kind of get the idea. I want to do, let me scribble this. This is going to be weird, but what I want to do is, if I have some sort of a form, right, and it gets wet, the bottom part of it gets wet, or other way around. Yeah, actually, yes. Sorry, I was thinking. So the bottom part gets wet, it will expand, right? While the top part is not wet, so it's going to kind of stay as it is, right? So what it's going to do is it's going to bend, right? It's going to bend like so, because the bottom is expanding and the top is not, right? So we're gonna try and do that by taking a surface here in the bottom, and that surface is divided up into parts, right, into polygons, and we have an identical surface in the top that's also made out of parts, and we interconnect them. Oh my God, I've just missed that line. But we interconnect them with this kind of a system, the X system, so that they are like every node between these two surfaces are completely tied together, and it's a rigid structure. I don't have the words to explain it well, but basically, if you have a structure like this, then it's all of the connections are interdependent. If you just had a structure that was like this, then it would be, it could bend, for instance, this way, it could have this kind of a shear bending, right? Where it just tilts. But if you have it cross-braced, it can't tilt, meaning it's a stable structure, and it's going to be a much more accurate representation of how the geometry would bend because of the moisture. Anyway, so that's the idea. So I have the surface here in the bottom, and then I'm going to move it. Or no, let's create. Do we need to create a mesh from it? Not really, huh? But let's still create a mesh from it. A simple mesh. Simple mesh from these BREP. So we have a lot of, like 6 meshes here, and we use join mesh or mesh join to join them up into one big happy mesh. Okay, so that is done. We have a bunch of meshes here, and then one single mesh here, and then we move that mesh up by in Z direction by, I don't know, like, let's do 5 for now. We can always change this, right? So let's just do 5 for now. So we have the bottom layer and the top layer, right? And the bottom layer is going to expand while the top layer stays the way it is. Okay. So now for the cross bracing, right? I need, let's maybe first create cross bracing for, let's just work on the bottom layer for now. And let's just create cross bracing right here, right? For every polygon, we create an X. So I'm going to say, give me face boundaries of this mesh. So I'm getting basically a polyline around each face of the mesh, face boundaries. And then for these face boundaries, give me discontinuities, corners, basically corner points, right? So I get 4 points for every polygon. And then I will separate those corner points into separate outputs. List length. List length? Nope. What am I saying? List item, not list length. List item can be used to separate these points. So this is point number 1 in the list, or number 0 actually. Point number 1 is here, point number 2, and point number 3. So I have 4 points here as separate outputs. And now I'm going to just connect them, right? So I'm going to say, if this is 0, 1, 2, 3. So 0 needs to connect to 1, or sorry, 0 needs to connect to 2, and 1 needs to connect to 3 with a line. So I'm going to use line tool, line between 2 points, this one right here. And I'm going to connect 0 with 2, bam, like that. And then I'm just going to copy it, copy paste, and I'm going to connect 1 with 3, bam. I have an X now. Great. So this works, right? And now I need, so this is a separate line, this is a separate line, and these are polylines. So I don't want them to be polylines. So I'm just going to explode these rectangular polylines here to separate line segments. And then I'm going to merge all of this, like these separate line segments, these and these, into one list, right? So for that, I will use merge. Merge. Segments go into D1, lines go into D2, lines go into D3. There we go. Everyone is in one list. Well, not quite, because you can see this dashed line. It means that there's a data tree going on here, and I don't really want a data tree here. So I'm just going to, for the output, I'm just going to flatten everything out, right? So now everything is definitely in one list. But there is one thing that we still need to fix. This polyline, right? This rectangle and this rectangle, they share one edge here, which means that there's a duplicate line here. Like there are 2 lines here, right? I want only one line to be here. So what I'm going to do is I'm going to say remove duplicate lines. Remove duplicate lines like that. And it basically gets rid of all of the duplicates, right? It just keeps one instead of two. I can hide all of that. And now we have our cross bracing for the top done, right? I can just group it like that. I'll copy, paste it here, and use it for the top mesh as well, right? So all I need to do is just, bam, do that. And I have the cross bracing for the top. So that was the easy part. The hard part is going to be the sides, right? But that's also, I don't think that's going to be super, super hard to do. So for the sides, let me just check how I did it. Yeah, all we needed to do was just shift, right? Yeah, that's fine. Okay, so we just shifted. So here we have phase boundaries, and here we have phase boundaries, right? Let me just show you. Bam, bam. These phase boundaries. And these phase boundaries have discontinuities. And I'm going to do the discontinuities again. I know that I could reuse the discontinuity nodes here, but I want to keep things clean. So discontinuities come in from here, and discontinuities come in from here, right? So I have these points. And I can actually show you the numeration, the numbering of these points by using point list. Point list tool, bam, like that. And then using size. Just a second, thinking. This is in millimeters, so let's use size 2. Like that. And then copy paste. Like that. Okay. So now you can see the numbers for these points, and here where we have duplicate points, there are 2 numbers, but it's basically they match, right? So 0 above 0 we have 0, above 1 we have 1, above 2 we have 2. So what we can do to create the diagonal connections, well actually to create vertical connections between these, all we need to do is just do line between these points and these points. That's it. We have, 0 connects to 0, 1 connects to 1, 2 connects, and so on. So we have vertical lines. There's duplicates here, but we will fix those in a second. The trickier part is the X cross bracing. And to do that, all we need to do is say that 0 needs to connect with 1, and 1 here, from here, needs to connect to 0. So we need to shift the list forward by 1 item, and then we need to shift the list backwards by 1 item, right? So for this, we will use shift list, and we will use, it doesn't matter which one we shift, by the way, the top or the bottom, that absolutely doesn't matter. So I'll just shift the top one, well, the geometrically top one, but in the definition, it's shown in the bottom. I'll shift that list, and by default, it shifts by 1, right? Which means that already I can, actually, let me delete this so that it's not so much in your face. So now with line tool, it already will create a diagonal connection like so, right? 0 connects to 1. 0 to 1, right? And now if I shift the list again, and I know this is getting cramped, I'm sorry about that, but if I shift the list again, but this time by -1, I'm just creating a panel here saying -1, or you can right click on the S input, go to set integer, and here you can type in -1, doesn't matter. But if I shift it backwards by 1, and I create a line again between the original and, not the original, sorry, but the bottom point cloud and the shifted point cloud, now I get the X cross bracing here. That's done. That's it, right? We have it. everywhere where these boxes now they kind of look like boxes, right? So everywhere where they meet, it's going to be a bunch of duplicate lines. So we'll need to fix that. But we already know how to do that, right? We merge everything into one big happy list, like that. We flatten out the output, and we remove duplicate lines, like that. That's in Kangaroo 2, by the way, remove duplicate lines. And we have that. Part done. Okay. So now, what do we have? What do we have here? We have duplicate lines here, or sorry, removed, cleaned up lines in the bottom, in the top, and in between, right? So now we need to come back to our idea of how that whole expansion is going to work. The ones that are on the bottom, these ones right here, are going to expand, right? And these, as well as these two, like the sides as well as the top, are going to try and keep their original length because they're not wet, right? They're not expanding. So I am going to say, well, I'm first going to merge this and this, like the top as well as the sides, to one list just to keep it clean, right? And here I'm just going to have this as separate output. So now it's time to actually use Kangaroo. Not Kangaroo, sorry. Kangaroo 2 uses solver. So we're going to use a Kangaroo solver. For goal objects, we are going to use an entwine. This will just help us kind of make a data tree and keep everything, all of the inputs clean, right? So entwine. And for the output, we will use bang, explode tree, right? So we're basically creating a data tree and then we're exploding it into separate branches. That's it. Then we will need a reset button, and an on and off switch, which is going to be a toggle. Oops, like that. Okay, so we have our initial Kangaroo setup done. So now what are the goals for our simulation? Well, goal number one is always show. We're going to show some sort of a geometry after the simulation has finished, right? So that's our goal number one. What kind of geometry it is? Well, we will still need to make it nicer, but it's basically going to be the bottom mesh as well as the top mesh, and do we color code it? Let's color code it, right? So let's color code the part that actually expands, right? And the part that actually is going to expand is going to be the bottom mesh right here. So that is going to come in as a separate mesh. So I'm just going to kind of straight up connect it to show, like that, right? But for the top mesh, what I want to do is I want to take its mesh edges. I want to take all of its naked edges and I want to extrude those naked edges in Z direction. Or actually, we can just use this one straight up. So we are moving it up by 5, right? So we need to extrude the perimeter of it down by -5, right? Because it's down, right? So this, I will just use negative value of this vector, and I will just straight up connect it to the D input here. And that's it. We have our... Wait, what the hell is that? Wait. Something strange. If I delete this, no, this is clean. Okay, never mind. Sorry. Just a visual glitch. Okay, so now I've just extruded the perimeter down by 5, and I will just convert it to simple mesh. So this extrusion, or these extrusions, are being converted to a simple mesh, and they're going to be joined, mesh join, they're going to be joined with the top code, right? With this. And simple mesh, holding down the shift key, gets joined up here, right? And just in case, I will right click on the M input and choose to flatten so that everything is flat. Right? Everything is in one list. And then again, holding the shift key, I will connect it to the show input right here because we will want to show it. Bam, like that. Okay, this is a little bit messy, but it is what it is. Okay, so our show input is done, and we can see that bang actually gives us an output. And let's look at it. So the output that bang gives us is 2 meshes, right? The ones that we are telling Rhino or Kangaroo to show. So I'm going to use list item to separate them into 2 separate entities, first and second one. And I will use custom preview for the first as well as the second one. And I will use color swatch to control the color of both of them, right? So now for the bottom one, I will change the color to blue. And for the top one, I will change the color to maybe purple. Come on. Oh, purple is whatever. Let's go for dark pink, right? So we have blue that is going to be expanding, and we have dark pink that is going to be just not expanding, you know, the rest of the geometry. Okay, so that works. And actually now we can make this thinner, right? Like that. Okay, next up, expansion, right? The actual expanding part of it. So that is actually quite simple. Under Kangaroo 2 tab, under goals line, you have line length, or length in brackets line, like that. And it's asking us to give it a line segment. So I'm going to give it all line segments that are in the bottom, like so. And it's asking us to give it a length, right? And we don't really have a length for them, right? So I'm just going to say measure the length. So what's the measure the length of a curve? Just type in length, right? And measure the lengths. And we can multiplication, the lengths by a factor, right? So let's say if we have a slider that is that starts at 1 dot dot and ends at 2. And actually, let's give it 2.000 to give it more resolution for the slider. So a slider between 1 and 2. I connect it to the multiplication. What it does is basically takes the lines, takes their original length, and if we have it set to 1, it keeps them as their original length. If we have it set to 2, it makes them larger, right? It expands them twice to 200% of their initial size. So it just multiplies. I connect it to length like so, and connect the spring output to 0, 1 input of entwine. That's our second goal, right? If now I reset and run the simulation and actually expand this, you can see that it's kind of boring, right? It just basically scales. scales everything up. Nothing fancy, right? And then scales everything back down. Really nothing fancy. That's because there's nothing that would restrict the scaling, right? So now it's time to actually make it restrictive. For this, I need all of the remaining lines not to expand, or try not to expand. So I'm going to use length line again. I never can find it. Goals line, length line. This one again. This time I'm going to use all the rest remaining lines. I'm still going to use the length measurement, but this time I'm just going to connect it straight up into the length input here. I think even if you don't do it, it's, what does it say? Length. If none provided, starting length will be used. Okay, so even if we don't connect anything to this, all of the lines will try to keep their original length. So that's great. We just keep it this way and just connect it to 0, 2 input here. Disable preview of all of this. Moment of truth. Reset, play. Okay, nothing exploded. That's good. That's always good news. Expand. Bam. Bending. Yay! We have it working. Okay, so now we have it working, and of course it's going to, you know, if you really break it, it's gonna break. I mean, there's no denying of that. But it is working. Sweet. Now it's time to actually work with this, right? With our Arduino. So the thing is, we do have this number that is, you know, constantly fluctuating. You know, actually, let me group this and change the color of this to white. There we go. So we have a number that is fluctuating, and I can kind of extract it just to keep things clean, like that, as a number. And we want that fluctuating number to influence to be here instead of the slider, right? So I'm going to, well, first of all, stop the simulation, delete the slider, right? And then think about how can we convert 828 to a more reasonable number, right? Because the 828 times the size of the initial curves will not work. So for this, I will use remap numbers. I will use remap numbers. And I will say that my source domain, right? So what's the smallest number and the largest number that I am expecting to get from this sensor? So the largest number is, let's say, 800, and the smallest one is, let's say, 400, right? So I'm just going to write dash dash 400 to 800, like that. There we go. So now we have a range between 400 to 800, and then our target domain is to what kind of a range do these numbers have to be remapped, right? So what's the smallest number then, and what's the largest? So again, I'm going to write dash dash. I'll say the smallest number then is 1, and the largest one is, I don't know, 1.3. That's how much it expands, or 1.4 maybe. How much it expands, right? Like that. 1 to 1.4. Connected to the target domain. So now if I look at the panel here, or the output here, I can see that it actually gives me a larger number than 1.4. That's because here it says 8.28, not 800. Or sorry, 829, 828, not 800. So it goes beyond my, you know, my boundaries here. And I think if I put this sensor again, I keep putting it in my mouth. I need some, you know, oh, I can put it in my cup of coffee. If I put it in my cup of coffee, never mind, that's not good enough. So let me put it in my mouth actually. See how it went lower than 1? That is because it went below 400. So I need to have hard caps for 400 and 800, and it's very easy to do. I just do minimum, and also I will do maximum. So my minimum number is going to be 400, I think. Oh, sorry, not 400, God damn it. We're dealing with these numbers now. So my minimum number is going to be 1.4. No, it needs to be 1, isn't it? Wait, let's check. No, it does need to be 1.4 because it gives you the lesser number of the two. So minimum connects to the larger number here, and maximum then we run this through maximum again, and it connects to the smaller number here, which is going to be 1. Like that. That's it. That's all we need to do with the numbers, right? With the number part. Now we have a slider that is constantly going to connect to values between 1 and 4. Not a slider, but rather a number that's going to fluctuate between values that are between 1 and 4, 1 and 1.4. The only problem is that if it's dry, it gives me a large value, and if it's wet, it gives me a low value. So I need to reverse these. So I'm going to say, instead of 1 to 1.4, I'm going to say 1.4 to 1. That's it. That's it. That should work. Now it's by default going to give me small numbers, but if I and it's also not going to fluctuate. But if I kind of touch it, that's a cool bug right there. But if I touch it now, it gives me a larger number, right? Okay, that works. Let's just straight up connect it to length line and see what it does. Bam, like that. Reset, run. Are you ready? Wait. That. Okay. Here's my sensor, and bing. Okay, that was way too much. That was way too much. Instead of 1.4, let's do like 1.1. Reset. We try again. Look at this. Bam. Bam. How cool is that, huh? I mean, yeah, it's a floppy thing. It's nothing special right now, but imagine the possibilities, you know? It's right now we're just dealing with a moisture sensor. There is light sensors, there is proximity sensors, there's the CO2 sensors. So if you breathe on a model, it's going to do something. There's a lot of different possibilities here. And I'm going to definitely work with those and try them out, try to see how those work. For now, for this, just to finish this tutorial up, I'm just going to take these surfaces here, and I'm just going to make a copy like that. And make a copy, not open, copy. Like that. I just want to see how fast this is. You know, if this is gonna lag or not. Set multiple. So it's breaking. That's cool. Reset. It's working. It's a little bit laggy now, but that's expected. And now I'm just gonna. Oops, that's the wrong camera. There we go. Put it here. And 1, 2, 3, go. And release. Mouth. Nom 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 nom. Nom nom nom. Nom nom. Okay, enough playing around. This works. Another successful tutorial. But wait, there is more. So Wingfox has contacted me a few weeks ago offering a collaboration where I kind of showcased the courses that they offer, and in doing so, I received like a 10% or something like that commission from every sale that they will do through my referrals. And I went through all of the courses that they have, and I found one that I really enjoyed and that I would like to kind of advertise, I guess, for you. And that's a Blender course, and I think I have it here. Yeah, there we go. That's a Blender course. And it's basically, the link to it is in the description. It's $39 to get it. But the nice thing about it is that they give you all of the material, all of the 3D models and whatnot, and all of the Blender files together with the course. So it's not just videos that you're getting, which I think at that point, it justifies the price of $39, right? And it's a sci-fi, special effects course on how to do motion graphics and so on. Actually, that one, I finished up this course and I did this little video right here with, remember the sub-D house that we are doing in the live streams? By the way, I will continue the live streams soon-ish. I did a small test video, of holographic kind of a presentation animation thing. Worked out quite well. So that's our sub-D house right here, right? So it kind of, the courses seem to work. Let's say it like that. So if you're kind of interested in it, check it out. By the way, just above my head, pop, nope, that's the wrong one. Pop, that's the correct one. Just above my head is a code, right? If you use that code, I think you will get 10% more off or something like that. So you can use that code. What else? Yeah, the link to the course is in the video description. I need to get better at ad reads, I guess. If this is even an ad, it probably is. Feels like an ad though. Anyway, back to our little definition here. So this definition is indeed, you can build it yourself. It's not that big of a definition, but if you're super lazy, as per usual, it's available for my Patreon supporters. Right. Next up, on this YouTube channel, we're going to kind of look deeper into robotics and architecture, and not just architecture, in robotics in general, and how can we bridge that gap between the physical and the digital, right? Through sensors, through using Grasshopper to actually control a physical model, be it architectural model or be it a robot in reality. But that's at least where next few months of this channel is going to head. Once that is done, I have no idea. We will just find another really cool thing to investigate and to learn about. So, hope you enjoyed this one, and I'll see you next time. Later.